So this lesson is transforming quadratics or transforming parabolas. And what we're going to do in today's lesson is we are going to look at a new form for the equation of a quadratic relation. Okay? This is going to be called vertex form. And you can see what that form of the parabola is right in here. And what we want to do by the end of today's lesson is understand the significance of these parameters a, h, and k that appear in this form of the quadratic equation. And we also want to recognize what transformations are applied to the graph of a very simple parabola, y equals x squared, to obtain the graph of a parabola that has this equation here. And basically we want to be able to make a connection between the values of a, h, and k and how we have changed the graph to get our new parabola. So just to take a step back a little bit, we have been working primarily with quadratic functions in standard form, and then we have taken standard form and we have factored it to get it into what we've called factored form. And so an example of standard form is down here, x squared plus 7x plus 10. But we found factored form a little bit more useful because after we had factored it, and of course these two things are not equal to each other, but this is just an example of a factored form quadratic equation. This form let us figure out what the x-intercepts are. We knew just by looking at this that our x-intercepts are x equals -5 and x equals -2 because those are the places where those are the x values that would make this equation equal to 0. So here is our new form. This is called vertex form of a quadratic function. Y equals ax minus h squared plus k. And as I said at the beginning, our job is to figure out what does this a mean in terms of what our parabola looks like or what properties it's going to have. What does h mean in terms of the properties of our quadratic or our parabola? What does k mean? What is it? What do these values of a, h, and k, which are just these are all just numbers, what do they tell us about our parabola? What key information about the graph of our function can we get from this form? And to do this, we're going to look at a bunch of different parabolas that have this in this form of the equation. Okay, and we're going to take all of these parabolas that we look at and we're going to compare them to the simplest possible parabola that we can come up with, y equals x squared, which you see graphed over here. So this is the simplest one. Like we can imagine going from y equals x squared and putting it in this form y equals ax minus h squared plus k. The values of a, h, and k in this one would just be 1, h would be 0, and k would be 0, because we could write this as y equals 1 x minus 0 squared plus 0. And if we do some simplification here, this would work out to be just x squared. Okay. And we want to ask this question down at the bottom here. How does changing the values of a, h, and k change the graph of the parabola? So a couple of things that we're going to zoom in on when we're looking at how the graph changes are, we're going to look at the vertex. So we know that in our original parabola, the vertex is here at 0, 0. Okay. So we're going to look at how changing these values changes the location of the vertex. The other thing we want to keep in mind is what is the shape of the parabola. So our vertex is here at 0, 0. I want you to kind of notice that two other points that are on the graph of our parabola are at the points 1, 1 and -1, 1. So we've got this little pattern here that from the vertex we can go over 1 and up 1 to get to the next point, like this and like this. And we can also do this in the negative direction. Okay. We might refer to that pattern later on when we talk about the shape of the parabola. All right, let's start with changing the value of k. So k is this number that gets added on to the end of our parabola. So we're going to look at 3 different parabolas here. All of these are going to have an a value of 1. Okay, so this number up front is going to be a 1 in each one of these, and an h value of 0. H is the number that appears inside the brackets with the x, and if we don't see a number inside the brackets, h has to be equal to 0. So we're going to start by looking at y equals x squared plus 1. And then we're going to move on to x squared plus 3 and then x squared minus 4. And we're going to look at how this changes the graph of our parabola. So y equals x squared plus 1. You can see it over here to the right. And what you notice, obviously, in our equation here, our k value is equal to positive 1. And what has happened to the graph of our parabola here? Well, we have shifted the vertex from 0, 0 up to 0, 1. Okay, so we've just taken our parabola and we have shifted it up 1. Okay, notice that the shape of it hasn't changed. If we go from the vertex of our new parabola, we can go over 1 and up 1 and get to these two other points here. So let's look at x squared plus 3. You can see it here. We've got now k value is equal to positive 3, and you can see that this has been shifted up 3. And our vertex is now at 0, 3, right here. Okay, let's look at our next one, x squared minus 4. This looks like this. We have our k value here is negative 4, okay, because we have that negative sign as part of the k value. We notice that our parabola has been shifted down 4. Our vertex has moved from 0, 0 to 0, negative 4. So at this point, we can probably sum up. Changing the value of k shifts the parabola up or down. Depending on the value of k. It shifts up k units, I guess, if k is greater than 0. Okay, and it shifts down k units if k is less than 0. So if k is negative, it's going to go down. So those are two possibilities. All right, let's move on here and look at what h does. Okay. So again, we're going to look at three parabolas here, and we're going to change the h value, or that number that appears inside the brackets with the x each time. And in each one of these, a is going to be equal to 1, and k is going to be equal to 0, because we don't see a number out in front multiplied, so we know a has to be 1, and we don't see a number added or subtracted on the end, so h has to be equal to 0. And again, we're going to compare these to our original graph of y equals x squared. So let's look at x minus 1 squared first off. So what we can see here is that in this parabola, our h value is going to be positive 1. Now, why is it positive 1? Because we expect in our general form there to be a negative sign here. We expect it to be minus h. So if we see a minus sign right in here, what we're doing is we're doing x subtract plus 1. So h is equal to positive 1. How has this changed the graph of our parabola? Well, our vertex has been moved over here from 0, 0 to 1, 0, and our parabola has been shifted to the left. Sorry, to the right. 1 to the right, and our vertex is at 1, 0. Notice the shape of our parabola hasn't changed. We can still, from our vertex, go over 1 and up 1, or back 1 and up 1 to get to our next point. So let's look at our next one here, y minus 3 squared. Here we can see that our k value is positive 3. Our parabola has been shifted 1, 2, 3 to the right. And our vertex is now at 3, 0. Okay. Our last one here, x plus 4 squared, is going to look like this. Our h value here is negative 4, okay, because we can imagine this is x minus, is our general form, negative 4 all squared. Those two negative signs will combine to give us this positive sign in the middle. what has happened to our parabola? It has been shifted 4 to the left. Our vertex is at the point -4, 0. Okay. So clearly, changing the value of h shifts the parabola left and right. We're going to the right, h units, if h is greater than 0. So if h is positive, we're going to the right. It shifts it to the left, h units, if our value for h, sorry, not k, but h, is negative or less than 0. So together, these values of h and k shift our parabola either up and down or left or right, and together they're going to determine where the vertex of our parabola is. So in each one of these ones that we've done right here, notice that our h value is +1, our vertex is at 1. Our h value is +3, our vertex, the x-coordinate of our vertex is 3. Our h value is -4, the x-coordinate here is -4. And k is 0 in each case. It's telling us the y value of our vertex in each one of these. Okay? So together, values of h and k give us the vertex, the coordinates of the vertex of our parabola. Okay, let's look at what happens when we change the value for a. So in each one of these, we are going to keep h equal to 0 and k equal to 0. Okay, notice we don't have, in any of these ones listed down the side here, we don't have a number inside the brackets with the x. We don't have a number added or subtracted on the end. So for all of these, we know right away that our vertex is going to be 0, 0, our value of h and our value of k. All right, what do we have when we have y equals 2x squared? Well, it looks like this. And what we've done, what it looks like, is it looks like our parabola is a little bit narrower. But what we've actually done is we have stretched our parabola vertically. We have taken these 2 points here and here, and we have moved them up here and here. Okay? Or, I mean, we've taken this point here and here, and we've moved them up to here and here. So if our a value here is 2, our parabola is stretched vertically by a factor of 2. Okay? Because what has happened is this point here that has that was originally 1 above the y-axis has gone up to here, where it now is twice as far away. It's at 2. This point that was right here at 4 has gone up to here, where it is now 8. Okay, so we've made each of these points twice as far away from the y-axis, so stretched it vertically by a factor of 2. All right, what if we make a equals to 3? Again, we can see it's gotten even narrower. So our a value is 3. This is a vertical stretch by a factor of 3. Because we've taken this point, let's do this in red here, that is at 1, 1, and we have, so it's a distance of 1 above the y-axis. It's like this is 1, and we've moved it up to here, where this distance is now 3. So it's 3 times as far away from that x-axis. Our last one here, y equals 1/2 x squared. You can see that our parabola has gotten, it appears to have gotten wider, but so we call this a equals 1/2. This is a vertical compression. By a factor of 1/2. Okay, so we've taken a point, let's say a point that is right here. We'll do this in blue here. Okay, it's originally a distance 4 above the x-axis, and we have moved it down to here, where it is now 2 above the x-axis. So we've squashed this parabola down. We've made everything half as far away from that x-axis. So changing the value of a, let's say, stretches or compresses the parabola vertically. Okay, so it's a stretch if a is greater than 1, a is positive. It's a compression if a is less than 1, but greater than 0. Okay? It's a fraction, basically. Now, what we haven't considered in each of these cases, our a values were positive. What if we make our a values negative? So again, we're going to keep h at 0, k at 0. So our vertex is still going to be at 0, 0, but we're going to change our values of a so that they are negative. So let's start by looking at y equals negative x squared. Our a value is negative 1. And what has happened here is our parabola has basically been flipped over. Okay, or we can say it's been reflected in the x-axis. Now, because the a value is negative 1, we haven't changed the shape of it yet. Okay, notice that this is still like that little pattern in there, and those first 3 points is exactly the same. Okay, but if we make our a value negative 2, okay, and I've left y equals negative x squared up there for comparison, again, we're still reflecting in the x-axis, but we're also adding in this vertical stretch. We're taking this point and we're moving it twice as far away from the x-axis. So it's a reflection and a stretch by a factor of 2. And our last one here, negative a half x squared, okay, again, it's still reflected in the x-axis, so we've made it concave down from concave up, but at this time, there's been a vertical compression. So a is negative 1/2. We still have the reflection, but we have a vertical compression. Okay. So changing the value of a to negative reflects the parabola in the x-axis. Or we could say that it makes it concave down. And depending on the value, we could say and it stretches or compresses it, just like it did when a was positive. So a can do, changing the value of a can do a lot of different things to our parabola here. So a quick summary. K shifts the parabola up or down, okay, depending on whether it's positive or negative. H, this number that appears in the brackets, shifts it either right or left, depending on whether it's positive or negative. H and K together determine the vertex of the parabola. It's always HK. If A is less than 0, our parabola is concave down. If A is positive, our parabola is concave up. And if the number we see in terms of A is bigger than 1, we see a vertical stretch by a factor of whatever A is. And if A is negative, if A is the value of A that we see is like a fractional value that's between 0 and 1, we have a vertical compression by a factor of A. Okay, so the parabola in this case would get narrower. Parabola here would get wider. It would appear wider as a result of that stretch. Okay, so let's apply this to answer a question here. Here we're given the equation of our parabola in vertex form. We want to state the values of a, h, and k, the coordinates of the vertex, and the transformation applied to that y equals x squared to produce this function. Well, let's just look at this. We know that a is equal to negative 0.5 right here. We know that h, this number in here, is going to be negative 4 because we expect to have a negative sign in there. So there must be a negative, another negative on h to give us those two negatives and making a positive. And of course, k is out here at the end. K value is negative 2. What transformations do each of these represent? Before that, we should say the vertex. A vertex is going to be given by negative 4, negative 2. Obviously, our value for h and our value for k. And let's sort of do these, well, let's do them in order that's kind of, let's do them in this order here. A equals negative 0.5. We're going to have a reflection in the x-axis because a is negative. And we're going to have a vertical compression because a is a fraction, or this, we can think of this as negative 1/2. Vertical compression by 1/2. So all the points in our parabola are being made half as far away from that x-axis. Our h value of negative 4, this is going to shift the parabola left, okay, because it's less than 0, 4 units. Our k value of negative 2 is going to shift our parabola down 2 units because k value is negative. So what does this look like in action? If we start from this parabola, y equals x squared, we can shift it left 4. We can reflect it in the x-axis. We can compress it vertically by a factor of 1/2, making it slightly wider. And then we can shift it down. And this would be the graph of that new parabola. Okay? So notice one way to sort of key on these things is look at the vertex of our new parabola. Our vertex here is at negative 4, not negative 3, but negative 2, right? Our vertex started here at 0, 0, so our vertex has been shifted left 4 and then down 2. All right, last question. The following transformations are applied to the parabola y equals x squared. It's shifted up 5, left 4, stretch vertically by a factor of 3. State the values of a, h, and k in the equation of the new parabola. Well, if it's been shifted up by 5, that's telling us that k must be positive 5. If it's shifted left 4, oh, that's exactly like the one we just did. H has got to be negative 4. And if it's stretched vertically by a factor of 3, a must be positive 3. Not negative 3, because they would tell us that it had been reflected as well. So we're going to take these, and we're going to remember that our general form here is y equals a x minus h squared plus k. And let's just sub in these values to get our new equation. Y equals 3 x minus negative 4 squared, and then k is positive 5. And then in the middle here, we're just going to combine those two negative signs to get a positive sign. And that is the equation of our new parabola.